In this video, we will study voltage divider rule and current divider rule. These rules are derived from Ohm's law, and they provide us with a formula that we can use to quickly find the voltage across a resistor or the current through a resistor. So let's see how we can get these two formulas. First of all, I'm going to consider voltage divider rule. To explain voltage divider rule, I will use this circuit where we have two resistors, R1 and R2. The voltage divider rule is applicable when two or more resistors are connected in series. And if we want to find the voltage drop across any of these resistors, V1 or V2, quickly without actually solving the whole circuit, then we can use this voltage divider rule formula. Now, to derive this formula, we will rely on Ohm's law. And according to Ohm's law, if I want to solve this circuit, the first task I would like to do is to find the current I, which is flowing in this series circuit. To find the current, I will have to find the equivalent resistance of the circuit, which is the resistance R total in this case, and which is the series combination of R1 and R2. So therefore, this is equal to R1 plus R2. That's my total resistance. Now the current I that will flow in the circuit, we can find that using Ohm's law, that I should be equal to the source voltage divided by the resistance, R total in this case. So therefore, the current is equal to source voltage divided by R1 plus R2. This will give us the current. Once we have the current in the circuit, now let's go back to the original circuit, which is shown here. And now if I want to find the voltage drop across resistor R1, that should be equal to the current I times the resistance R1. So therefore, V1 should be equal to I, which is Vs, and then multiplied by R1 divided by R1 plus R2. Now this equation is called the VDR, the voltage divider rule. Similarly, we can find V2 should be equal to Vs times R2 divided by R1 plus R2. Now VDR gives us a quick way to find the voltage across any resistor. If we remember how to use this VDR equation, then we actually do not need to calculate the amount of current. We can just use this equation directly, and it will save us some time. However, this equation was obtained using Ohm's law by first finding the value of the current. So therefore, VDR provides a convenient way to find the voltage, but there is no new method or information that is contained in VDR. One thing that can be obvious about these two equations is that the equations says that the voltage across the resistor R1 or R2 is proportional to the source voltage. Of course, if the source voltage increases, then V1 and V2 will increase accordingly. Also, it is proportional to the resistance itself. For example, V1 is proportional to R1. So if R1 increases, V1 is expected to be larger. And similarly, V2 is proportional to R2. So this is VDR. And if you want to see a quick example, then let's consider a circuit in which I have, let's say, 3 resistors, and the source voltage is 10 volts. I have 1 kilo ohm and 5 kilo ohm, and let's say 4 kilo. So I have these 3 resistors, R1, R2, and R3. And I want to find V1, V2, and V3, the voltage across the 3 resistors. Of course, the polarity would be as follows. And I want to apply VDR. We can solve this using Ohm's law, first calculating the series resistance of the equivalent resistance of these 3 series resistors. But I just want to show how to use VDR over here. So therefore, the equation of the VDR is that V1 should be equal to the source voltage times the resistance R1, which is the resistor across which I'm finding the voltage V1, divided by the total resistance in the series path. So as I said earlier, VDR is applicable to series circuits. So therefore, the total resistance is R1 plus R2 plus R3. Then I will have 10 volts multiplied by R1 is 1 kilo. And then the sum of the 3 is 1, 5, and 4. So that's 10 kilo. K and K will cancel out. I will have 10 divided by 10, which is 1 volt. So therefore V1 will be 1 volt, which means that the voltage, so let's say the negative of the battery is our ground terminal, so which means I have 0 volts over here, I have 10 volts over here. 1 volt will be dropped across the resistors R1, so at this point I will have 9 volts. Now let's see, how can I find V2 using VDR? So V2 will be equal to the source voltage Vs multiplied by the resistor R2 divided by the total resistance, which is the sum of the three. So I'm going to call it R total. Vs is 10 volts, R2 is 5K, and the denominator is 10K. So therefore I have 1 over 2, which will mean 10 divided by 2, so that's 5 volts. So V2 is 5 volts. And we can see that if I have 9 volts on this side, 5 volt drop, I will be left with 4 volts over here. At this point, 4 volt. And of course, the voltage across the resistance 3, which is V3, must be 4 volts because we have 0 volts on one side and 4 volt on the other side. So it must drop 4 volts, otherwise KVL will not be satisfied. But just to confirm, we will use VDR to find V3, which will be equal to the source voltage times R3 divided by R total. Source is 10, R3 is 4K, and R total is 10K, which will give us 4 volts. As expected, V3 should have been 4 volts, and it is 4 volts. So this is the application of VDR. You can use it if there are 2 or more resistors in series, and we can find the voltage quickly without actually calculating the current. So it's a simple formula. If you can remember it, good. Otherwise, you can always go to Ohm's law and solve it that way. The next topic I want to discuss in this video is the current divider rule. The current divider rule, CDR, is applicable for parallel resistors. And we can find the value of currents in different branches or in different resistors using CDR. To explain CDR, I will consider this circuit where I have 2 resistors in parallel. We have a current source now, IS. So the amount of current that is produced by the source is IS. So IS is flowing in this branch over here. And IS is supposed to be dividing between these 2 resistors R1 and R2, which are connected in parallel. We can again use Ohm's law to calculate the equivalent resistance, and from there we can then calculate how much will be the voltage across each resistors, and that will give us the currents in each resistor. CDR is a quick formula that we can use to find the currents without calculating the voltage first. So this is very similar to VDR, but it's just opposite in the sense that it applies to parallel circuit instead of series circuits, and also here we will find voltage first, and from there we will calculate the current. So to derive the equation of CDR, I will first construct the equivalent circuit of the original circuit. So we have 2 parallel resistors, R1 and R2, and I will say that R total is the equivalent resistance. The equivalent resistance of 2 resistors in parallel is the R1, R2 divided by R1 plus R2. And now I can find the voltage that the source will produce, the voltage across this resistor R total, because we know that the current is IS. So therefore the voltage would be IS times R total, which is IS times R1, R2 divided by R1 plus R2. So this is the voltage drop across the resistor R total. And because the 2 resistors are parallel, so therefore both of them will have the same voltage across them. So that's basically the first step that we need to find this voltage. Now I know the 2 quantities, voltage and resistance, so therefore I can find the current I1 and the current I2. Now I1 should be equal to the voltage drop across the resistor divided by the resistor 1, R1. The voltage we already found over here. We will plug in this value, and that is IS times the quantity in the parentheses, but I have to divide that with R1, so therefore I'll be left with R2 divided by R1 plus R2. So I can now say I1 that I1 is equal to the source current multiplied by R2 divided by R1 plus R2. This is the equation of CDR for the current I1. Similarly, the current I2 will be equal to the source current times the resistor R1 divided by R1 plus R2. And this will be the equation for the current in the second branch. Now you see the similarities with the VDR, that the currents I1 and I2 are proportional to the source current IS. If IS increases, I1 and I2 will also increase. However, the difference is that now the current in branch I1 is actually proportional to the resistance of the other branch. So you see, I1 is proportional to the resistance of the other branch. So if the resistance of the other branch increases, then I1 will increase, which means that if I have the other branch is offering more resistance to current, which will push the current away from that branch. So therefore, more current will flow in branch number 1, which is I1. So therefore, it's kind of proportional to the resistance of the other branch. And it should make sense. You can say that, for example, if the other branch, the branch of R2, if R2 keeps on increasing until it becomes infinitely large, very large compared to R1, then I will have the numerator, which is R2, and the denominator, which is R1 plus R2. Now, if R2 is much, much larger than R1, then the sum will be almost equal to R2 only, because R1 will become insignificant. In that case, we will have R2 divided by R2, which will cancel out and give me 1. And that one, when multiplied with IS, it will tell me that all of the current, all of the source current will actually flow through branch 1, which should make sense. So that is a CDR. To see a quick example of CDR, let us consider a circuit in which we have these two branches. And I will assume that I have a current of 3 amperes that is flowing. And I have 1 kilo ohm resistor, which is my R1, and R2 is 2 kilo ohm. So this is R2. Now the two branches offer different resistances, and which will mean that the currents in these two branches will be different. The current which is provided by the source is IS, which is 3 ampere in this case. Now you see R2 is larger resistor. So therefore, it will offer more resistance to current, which means less current should flow through R2. This is our intuition, and let's calculate the currents I1 and I2, and we will see that more current will flow through R1 and less current will flow through R2. This is I1 and I2. According to CDR, the equation is over here, as you can see. So according to CDR, I1 is equal to the source current multiplied by the resistance of the other branch, which is R2, divided by the sum of the two, so R1 plus R2. So therefore, I have 3 amperes multiplied by 2 kilo and divided by 3 kilo. Kilo and kilo can cancel, 3 and 3 can cancel, so this will be 2 amperes. So we find very quickly that I1 will be 2 ampere. If I1 is 2 ampere, if 3 amperes come from the source and I1 is 2 ampere, then you can easily tell that the current in R2 should be 1 ampere, because the current has to divide into two pieces and the sum of those two pieces has to be equal to 3 ampere. So let's just use CDR to verify that. I2, according to CDR, should be equal to IS times the resistance of the other branch, which is 1 kilo in this case, divided by the sum of the resistors, which is 3 kilo. And then I have 3 amperes times 1 kilo divided by 3 kilo. which is equal to 1 ampere. As expected, 2 is 1 ampere. And you can see that more current flows in the branch which offers less resistance. So this verifies CDR. Now that you know the currents in each resistor, you can also calculate the voltage drop across each resistor, which in this case should be the same because the two resistors are connected in parallel. That's it for this video. I will see you next time, and bye for now.